Okay, so now we need to find the reactions that are acting at this point. So we'll take out this portion and draw it separately and see what are the reactions. So one of the reactions will be acting in this upward direction here in order to hold this portion wherever it is. Another will be here. So these are the reaction forces we do not know. We know that there is an NF acting here. Now we have to analyze. Whenever you analyze a portion of the bar, you do not see the forces that are applied on to the bar, but you see the forces that are applied by the. I mean, you don't see the forces applied by the bar, but forces on the bar. So here, this force in this direction is applied by this bar onto this structure, right? Onto this structure, and therefore the same and equal and opposite reaction will be applied onto the beam by this structure, right? So this time the reaction that will be acting will be in this direction. I hope you get it. We have to analyze the forces which act on the bar, not by the bar, right? So this bar was pulling up this L and stopping it from rotating it downwards, and therefore it is pulling it by that force. But it's Newton's third law. Every action has an equal and opposite reaction. So that is the action that it is doing onto this L bar, and the reaction generated is on the opposite side, which is trying to pull and tear it apart onto the right hand side. So the force is acting on this direction. Okay, now we have to find what will be the forces. We do not know the directions of these, so we'll just write it down. Like this is a VG and this is an NG, right? So VG and NG, and we know this force to be 9800, and since it is acting on the positive x direction, so when you equate the x, when you do the f of x equal to 0, summation of f of x is equal to 0, and summation of f of y equal to 0, you find out that ng is equal to, because ng plus 9800 should be equal to 0, and 9800 is positive, so you send it on the other side, you get an ng equal to 9800 newtons, right? This equation came from equating f of x is equal to 0. Like all the forces acting on the x direction, we equate them, we add them, and we put that equal to 0. And all the forces acting on the y direction, which is Vg, we do not know the direction, so we will not put any sign there, plus anything, plus 0. There are no other reactions or forces acting on the vertical direction or in the y direction, so there's just Vg, and that is equal to 0. So we found out the two values of ng. So we know now that at this particular point the internal loadings is ng equal to minus 9800 Newton, Vg is equal to 0, and there is no moment because there is only a horizontal force which will not create a moment at that point. And if we try to pull it like that, it's not going to rotate, right? But if there is a force acting somewhere there, it might rotate at that point in this direction. So there will be no forces. Since there are no forces in the vertical direction, there will be no moment at G. That will be equal to 0. So we found out the internal loadings at point G, right? Now let's find out the forces ND and VD. I don't know where did VD disappear, but it was right here. So ND and VD, we need to calculate the forces that are acting here. It is very simple to do that. Just take this particular bar, the L inverted L bar, and separately analyze it for the same equations, which is the forces in the x direction should be equal to 0, and summation of all the forces on the x direction should be equal to 0. Summation of forces on the y direction should also be equal to 0. Doing that, we write down ND here and VD here, and we calculate. So ND plus NF is equal to 0. Okay, we know NF on this particular thing is acted upon by this bar, and so it will be in left direction. It will go to the left, and therefore it will be a negative value, and which was 9800 that we calculated, right? So this is a negative 9800, so ND will be a positive 9800, right? Because ND will be equal to minus NF. I know you'll be able to do that. ND equal to minus NF, right? Sorry, I'm being a little lazy here. So, and NF is definitely in the negative, so NF is minus 9800. So minus minus becomes, negative negative becomes positive, so ND we found out to be 9800. Okay, the same we can do for VD. Now this thing is acting downwards, and downward force I took as a positive in notation. So let me write down the notation. Downwards is positive, and then clockwise, let me write that again. Positive and clockwise is equal to positive. Okay, the opposite is negative. So we have a downward is positive, and therefore VD will be equal to negative that much. Okay, since VD plus 600 into 9.8 is equal to 0, according to the summation of Fy equal to 0, forces in the y direction equal to 0. So we have a VD equal to minus, I think it is 5880. I'm not sure, you can do the calculations. So you got the forces VD. Okay, so now we'll go ahead and try to find the reaction RC, which is right over here. So in order to find this reaction RC, one of the best ways, it is always a very handy tool to find the moment at any specific point in the beam whenever you need to find any unknown reaction. So in this particular situation, we'll try to find the moment that is applied at this point, which is the point B. So at point B, we'll try to find the moment. One of the good things about this technique is that if you try to find moment at a specific point, the unknowns at that point, unknown forces that are acting at that point, they get rejected, and we do not need to consider them in the equations. So there are two unknown forces right over here. We will reject them because if these forces are acting at the point itself, it will not generally create any moment, right? So we are left out with one set of unknown reactions, which is VC and NC. These are the components that get generated because of the reaction force applied by the hydraulic piston. And we have another set of known values, which is VD and ND, which we just calculated. So I'll just go through it, and I'll write down the equation for sigma m at B is equal to 0. So it is sigma, which is the summation of all the moments created at the point B, is equal to 0. So I use this particular equation, and I'll write down this equation over here, and then I'll solve it, and then I'll go through each and every step so that it's clear.